Hello, welcome back. This is chapter 9 about hypothesis testing. So hypothesis testing has two parts in chapter 9 and chapter 10. So chapter 9 is more about the basic framework for hypothesis testing. And the next chapter, there are additional topics we need to study in chapter 10. So anyhow, let's start. So in the previous chapter, we learned estimation. So estimation and hypothesis testing are two major inference methods in statistics. And simply speaking, estimation is a method that is asked as an open question, right? So what is the value of this parameter? That is estimation. But hypothesis testing is more like a yes or no question. Is it correct? Like, for example, I have a hypothesis. Is it correct? Then your answer, you are going to look at the data, and your answer should confirm the hypothesis or reject the hypothesis. So, hypothesis testing and estimation are similar and they are related, but the form of the questions are different. Okay, so for example, as I said in the previous chapter, like if you ask about what the percentage of voters supporting a certain candidate, if you ask this way, that's an estimation problem. But if you ask the question like, do more than 50% of voters support the candidate, then this is a yes or no question. So it becomes a hypothesis testing problem. So your hypothesis is more than 50% of voters support the candidate. So that's what you need, the hypothesis you need to test. Okay? Another example. What is the mean gas price of gas stations in New York City? Then it is an open question. So the mean gas price is a number. So you can use any number to answer the question. So it is an estimation problem. But if you ask, is the mean gas price in New York City lower than $3 per gallon? Then it is again yes or no question, which is a hypothesis testing problem. Okay, so now I think it's intuitively understood the difference between estimation and the hypothesis testing. So far it is intuitive, but actually answering the hypothesis testing question is not that easy because of the hypothesis. In the end, it is kind of unfair. So I need to give you other examples to make you familiar with the way of thinking. So hypothesis testing framework is very somehow counterintuitive, right? So you may think it is not scientific or it's not fair, not neutral. I understand that is actually somehow true. So I'm going to spend a lot of time to help you understand the underlying philosophical framework for hypothesis testing in this video. Okay? So then let's think about a totally weird question. Suppose that I'm accused of a murder case, right? Suppose that someone died and somehow I am the suspect and I went to a criminal trial. And in the trial, there are some evidences, but they are not strong enough to completely prove my guilt. But on the other hand, I don't have any alibi either. So I don't have any evidence that I was not there. So in this case, so either side could not have enough evidence to make sure I am either the criminal or not. In this case, according to the legal system, what should be the verdict? What should the judge how the judge should decide here. Am I guilty or not? The answer is B. So this is called the presumption of innocence, right? This is one of the key principles in modern a legal system, right? So the defendant is considered innocent until proven guilty, or the burden of proof is on the prosecution, right? So I am innocent until I'm not. Until there are evidence that I'm not, right? So this is similar to the hypothesis testing framework. So this decision process is actually not fair, not neutral. It favors innocence over guiltiness, right? So if there is no evidence at all, then still you have to make decision, yes or no. And then in that case, even if there is no evidence at all, then the decision should go to innocence. The benefit of doubt is going to one side. So it is unfair, but the legal system, it is a very important way of thinking in legal decision. And this is not rare. Another example is the paradigm shift. You may have heard about this in the history of science. So in the history of science, there were several major paradigm shifts. Maybe one of the most revolutionary and most famous paradigm shift was geocentrism, right? So, in the old days, people used to believe that the sun is rotating around the earth. So we are the center of the universe, right? Just because we cannot feel any movement of the earth here, right? And it looks like the sun and moon are rotating us. But now no one is believing the geocentrism. And that happened, the movement or shift to the heliocentrism happened only when there are enough evidences that shows the geocentrism is not true, right? So before the revolution, just the geocentrism was believed, and even if there were several evidences that this geocentrism was wrong, still people tend to deny that. So until it is too certain it is too certainly wrong, then people change their mind. This is another unfair decision, right? Geocentrism was believed just basically without any evidence, right? Okay, another example. When you make the decision, usually people tend to be conservative, right? When you shop something, so when you shop a new pair of shoes, then usually people tend to buy the same item, right? Until they really don't like that. If I'm okay with the current shoes, then usually I go to the same shop, same brand, same model. So that's a typical tendency. You try another item only when you are not satisfied with what you are using, right? So that means even if neither you like or dislike, still your choice favors the item you are used to, right? So it is unfair. You have to compare all the brands without any bias. Actually, you are biased toward what you are familiar with. So that is realistic decision-making process. So in these frameworks, you can see the unfairness. People think in an unfair way. They have incumbent hypothesis or belief, and until it's proven wrong, people tend to stick with the belief. That is similar to the statistical framework for hypothesis testing. Okay? So statistically, we are going to formulate the problem this way. So for example, competing hypotheses are expressed in statistical parameters. Say mu is 0 or not. So I believe that the population mean is 0. But it may be wrong, but I will believe the mean is 0 until there are enough evidence against it. Another example, I believe the probability of success is at least 50%. It may be wrong, but I'm going to just stick to my belief until it's proven wrong, right? So we call the first hypothesis is called the null hypothesis. This is the hypothesis that you believe without any evidence. So without nothing, you believe that, so it is called the null hypothesis. There is no statistical evidence for that. It is null, right? But it is favored because you believe that. That is your belief. And we usually denote it as hypothesis 0, subscript 0 for the null hypothesis. So this is your belief. And then if you think it is wrong, then you are shifting to the alternative hypothesis. So literally it is the challenging hypothesis that will replace the existing one if the existing one is wrong. And we denote it as hypothesis subscript 1, right? So exactly all these frameworks are similar. I am not guilty. Innocence is the null hypothesis. When there is no evidence, you have to believe that I am innocent, right? And also, in this example, when there is no evidence, people used to believe that the sun rotates around the earth. That is the null hypothesis, believed without any evidence, actual comparison between these two options. And also, in your decision making, there must be some just default status quo decision that you are going to choose without thinking. So that is the null hypothesis. So also in statistics, you may ask a question already with some belief about statistical parameters. Then you have to set up a null hypothesis and an alternative hypothesis to start a hypothesis testing, right? And then once you set up those hypotheses, the final result of a hypothesis testing should be either of them, yes or no. There are only two possible results. There is nothing in between them. So I don't know is not your option. I'm not certain is not your option. You have to either reject the null hypothesis or accept the null hypothesis. That's the only two options. Like the judge in a trial must determine if the defendant is guilty or not. So there is no, he or she should not say, I'm not certain. So there should be a decision, okay? But what is interesting is, again, this decision is not like comparable, not exactly at the comparable level, because when you reject the null hypothesis, this is possible. You can reject the null hypothesis only when there is enough evidence against the null hypothesis. You can reject it only when you have enough evidence, so you are certain that it is wrong. So when you reject the null hypothesis, it is a strong conclusion, implying there are evidences. However, even if there is no evidence, you cannot reject the null hypothesis. So in many textbooks, it's usually said to accept the null hypothesis, but I don't like this idea. You are just, what is more correct is just not rejecting that. Because you cannot reject it even if there is no evidence. So when there is no evidence, you are not accepting that, but just you cannot reject the null. So this is a weak conclusion, right? So because even if there is no evidence, still you have to call this decision, right? So it is weak conclusion. So as you saw, by construction, the null hypothesis is favored over the alternative hypothesis because you just believe that, and that means and then there are two decisions, choosing null or choosing the alternative, but between them also one is much more stronger than the other, right? If you choose the alternative hypothesis, that means you have very strong evidence, so the strength is much stronger. And that means if you use hypothesis testing in your research, what you want is usually to make your argument stronger. You want to put the hypothesis, your hypothesis, as an alternative hypothesis, and then if you can choose your null alternative hypothesis by rejecting another hypothesis, that is a strong conclusion. So this is how we usually construct a hypothesis when you use it as a research tool. Okay. Here is a summary, right? As I explained, the incumbent, the null hypothesis, your belief, is called null hypothesis in hypothesis testing, which can be comparable to like presumption of innocence or geocentrism or just your go-to choices. Okay. Okay, so this is so general discussion, introduction of the framework. So from the next video, I'm going to use more specific example to add probability idea in this testing. How can we test it or not? Okay. Okay, thank you for watching. I'll see you later.